Okay, and welcome back to the bench. Today I'm going to talk a little bit about the underwriters knot, why it's used, strain reliefs, and actually getting into doing some work and why I use certain things while I'm working on a project. So get ready. We're going to dig right into the RCA 8X541, and we'll get some work done today. All right, so here we are at the radio. If you can see down here, there's two holes. This is where the power cord came in. What they used in a situation like this, when they put the wires through, whether it was twin lead, like parallel leads like I'm going to show you, or it was just twisted wires and each lead came through one of the holes. Nowadays, we have things like this that are strain relief that prevent the wire from being pulled through, okay? Here's one that's just a plug in and holds on. And years ago, they used to have possibly just a rubber grommet, and that wire could be yanked through. So what was used was, let me get my wire here. I'll show you the cord that came out of here. Okay. This is, let's see if I can get this right. Okay, doing this through the viewfinder is a little bit different than doing it. Let's get a piece of white paper back here so it looks a little bit better. You can see it better. Okay, so here you have your twin lead wire, okay? What you did was you put the wire through the holes, then you took this one and you put it through here, okay? So when this was in, and you'll see it once I do it in the radio. Okay, where are we here? So when this was pulled on, this was up against the chassis, that little cardboard that's there, and acted as a strain relief to where this was connected. You'll see how that works. I'm going to show you on the radio because that's one of the first things I want to get done. Okay, you can see how this comes up through there. And again, we're going to one lead like this. I know my big fingers are in the way. And then the other one comes around. Yeah, goes through there. Okay. I'm going to make this a little bit tighter. I'm going to go off camera and make it a little bit tighter. But when this is down on here, now that acts as a strain relief. Okay. Okay. Now you can see I fixed that up a little bit. Doing it on camera is a little difficult. But you can see the cord is right there. That cord cannot be pulled through. When these are connected to where they're supposed to go, I believe this was over here, I'll get this soldered up, but I want to show you why I use this, the solder sucker. If you can see, there's a big one. First of all, look at the way this guy soldered this. Cold solder joints, really bad. So we put this on here. Yeah, my hands shake a little bit. The hell, that's what happens when you get older. You start, just broke that off, which means it wasn't even soldered on. He left the old solder stuff in there. It's great. Okay. Sorry about that. Okay. Not sure if you noticed, but when I took that off, what he did was he soldered the loose braid right to the terminal. It all frayed, okay, which is not the right thing to do. Let me get my solder here. Okay. Best thing to do Get a little solder on your iron. And tin the lead. Okay. This makes that lead, oh, sorry, knocked the camera again. Makes that lead a little more solid and it'll stay in there better. Okay. Yep. Where's my, there it is. Vintage tools for vintage work. Okay. So now, when I put this in, yeah, okay, working around the camera here. Boy, I never realized how difficult it was. Guys used to always hear guys talking about working around the camera, and I'm saying, come on, how bad could it be? You know what you're doing. Now I understand. Never make fun of somebody unless you've walked in their shoes. All right, now, again, a little solder on the tip. Hope you guys are still in frame. Okay. And it's soldered. No big globs of solder, nothing solder running all over the place. And that's in there solid, okay? Very nice, smooth connection. Okay, so now through the magic of filming, you can see I can pull on this and these two wires don't move. That's what that strain relief is all about. That is the knot to use when you're doing something like this. Okay, if you also notice, yeah, I use Ace Hardware. There's a speaker under here, okay? Yeah, I could put my fat finger through the paper cone on here, but I do this, it protects it from any solder splatter. It protects it from my fat fingers going down in through it. Okay, that's another thing that you should learn to do to protect that speaker. Yes, I could disconnect the speaker. It's just more work. It was easier to put this on. All right. The next thing, this capacitor, which was probably not the original, was in here, okay? So the new capacitors came in, and I guess seem a little bit better there, are right here. I spread the clip open, put the two capacitors in, and I'll be hooking those up today, I think today. No, I won't. I've got work to do. If I start connecting these, I'm going to have wires over the top of where I have to work. So that's another thing you have to look at. Layering your stuff in. In order for me to get to this capacitor down here, I'm going to need to lift things up to work on it. So you need to learn to work in layers. Just like, why did I put the line cord on now? Because I have a part that has to go on over the top of it. Now that part is part of this, okay? If you remember, the chassis is not the ground. So there's a 22K and a 0.1 microfarad, or that goes across from B minus to the chassis. That capacitor was right here. The resistor is up here. Personally, I'm going to move the capacitor and the resistor right here. I'm going to parallel the resistor or the capacitor right over the resistor and install them right here in one shot. This will give me a little bit more room up here. I won't have this to worry about. And then I'll move up here and start working up here a little bit. Okay, I'm going to be jumping back and forth between the top and the bottom until I get in to the middle. And here's the layout of how to tie the underwriters knot. Okay, so yes, I did this work off camera. I replaced the capacitor, and like I said, I was going to put it right across the resistor. I didn't go right down because right to the where they connect, I left leads when I took it off because the current resistors and capacitors don't have enough length to go the full way, and then I used my pigtail across. Now the resistor was originally up here, okay? Did the same thing, but I moved it down here just to make it a little bit easier for me, give me some more space up here. Obviously, the two components were out of spec. This resistor, instead of being 22K, was 33K, okay? This was a capacitor that was part of, capacitor is part of the oscillator circuit, and instead of being 56 picofarad, it was 68 or 69 picofarads. So they both needed to be replaced, as well as everything else in here being so far out of spec. So I'm going to continue on with the work. I will catch you up and show you as things are interesting and I have to work in layers. Okay, so Stunad here realized when I did this work down here, you see it's not here anymore? That's because Stunad used the 22K, which was supposed to be up here, okay? This is the 220K. Supposed to be a 220K down here, and me, the Stunad, for not really, I picked up the wrong part and just went with it. Okay, so I have to redo this. I've done this work up here. I replaced the mica, the 22K, and I'll put this back in over here and continue with my work. Okay, moving right along. This capacitor's been replaced, okay? The 1 meg that goes from here to here is in place, okay? The remainders of the 220K, which I messed up on before, the remainders of that is taken off, okay? This, this all has to be reworked now. So I'm going to stop the video from now. I've got a lot of work to do, but I'll show you. Now I left this, see I put this here, I left this here. This way I know where it goes and I don't get messed up. Although I've taken pictures, I like to work in layers. So this is how I work in my layers. Okay, so I'm moving right along. I've actually changed this capacitor down here. I took the wire off that goes from here up to the 30 microfarad. This wire is going to be changed. You can see I've replaced this capacitor. It has to hook down into here. Again, I'm working in layers. I can't start putting these down here until I unloosen a lot of things. So moving right along. This is what we do and how we do it. The 3.3 meg capacitor resistor was replaced, and this can't get tied down because I still have to deal with all of this focaccia here, all this left in midair. I have to figure out what I'm going to do with that. Okay, well, we're moving right along. As you can see, I hope this comes into focus here. Let me see if I can get a better focus on this. Again, I have all my values showing, so anybody coming in here can see what the values are supposed to be. To me, that's very important. Okay, I've got almost everything done. I've got a couple wires to run from the volume control down to the second IF. I've got another wire to run from the rectifier tube up to here. I do have to connect this. I've connected the neutral. So we're moving right along. I get those connected, pop the tubes in, and we'll have a first fire up after all this work. Okay, so here we are. Hopefully I've done everything correctly. There isn't a component in here that wasn't changed. So every component in here was changed. If I did everything right, hopefully we'll actually get some noise out of this time. I'm not using a dim bulb tester, but what I have down below over here is my Sencor PR57. I've got the power turned all the way down, and I'm going to put it on current so that I can see the current as I'm bringing it up. And if there's a dead short, I'll see that current go up. I'll be able to shut it right down. And so let's go. So I'm bringing it up slowly. Yeah. You got to switch it on first, Freddie. There you go. I got it switched on. And I'm bringing the power up. So far, I don't see any smoke. I wouldn't be surprised. Well, let's see. I'm up to about 50 volts right now. No current draw to speak of. Now you can see hopefully you can see that. The dial bulb is coming on. I do have the volume turned all the way up. We're now up to about 85 volts. And now I'm at full power. Boy, that's tight. One of the things I forgot to really take a look at. Now, you can just barely hear that, but I can just barely hear it. I don't know if you can. Well, I could tell you I'm in New Jersey, close to New York City. This is WABC out of New York City. So I do have some work to do on it. I'm going to do some testing. Again, the second IF transformer down in here was replaced. And I'm pretty sure the first IF up here is the original. But again, the second IF is replaced. I'm sure I messed around with some of the tuning on it, so I'm going to have to go in and do a tune-up on it and see what we've got. But it's actually playing, which it wasn't doing when I first got it. When I did the test on it, the fire up, just to see what was going on. Okay, so this is where we're at. I'll continue this with a little bit of a tune-up. I'm not going to do the tune-up on camera, but again, we're starting to work. Okay, so this is going to wrap it up for today. I've got work to do. The radio is working, which is a major milestone from when I got it. When I got it, the oscillator wasn't running. There wasn't a component in it that was within spec. All had to be changed. I did all of that, and it's now playing, but it's not playing right. I'm now getting a 455 kilohertz tone through the radio, which I didn't get before, which is a good thing. So we need to do some work. Are the tubes bad? Some of the tubes were marginal. I don't have any spare tubes other than pulling them out of a radio that I already have working, which I have no problem doing. But let's see where it's at. This is a holiday weekend for me, so I am going to wrap this one up. Look forward to seeing you guys again next week. And if you click like down below, hit subscribe. I really enjoy seeing those subscribers. So if you can do that, make my day and my weekend. Take care and have a wonderful day.